I'm a little bit out of practice talking in English, but I will do my best. With a little patience with me. This work is from a student of my university, but unfortunately he couldn't be here, and he asked me to present for him. Again, I will do my best to ask your questions later. Maybe something I will have to pass to my student too. Later on, we can answer you. Well, what's the motivation for our work? We are trying to detect, identify and classify the trees in the urban environment. And trees, as we here in Belém know and feel, trees can reduce the heat island. I don't know if anyone risked to go by foot from the hotel to the IFPA. If anyone were brave enough, he must feel the heat, and there is a beautiful park from here to the way to the IFPA, and when we cross near the park, the temperature is wonderful, but when we step away from the park, and there is almost no tree until we get to the FPI, and the heat gets us, and I regret to go by foot after the park. Also, the trees works as natural air filters. In big cities, many cars, this is extremely important to get a cleaner air for us to breathe. And we experienced this a little time in the beginning of the afternoon when the rain fall. The trees can prevent the water runoff. If we have many trees, you have a better soil infiltration for the water, and you can prevent urban flooding. Also, but as important as the other topics, the mental health. It's completely different if we live near a lot of a place where we have a lot of trees. The way to get to places has a lot of trees, and if we only see concrete, the impact of the mental health is significant. But so this is the trees. I think it's established. The trees is extremely important for the urban environment, and we have to manage the trees some way. The traditional way, you can made by satellite imagery, but with satellite imagery we have broad areas of coverage, but often we don't have a sufficient resolution of these images. And this is critically in far from the main areas of the countries. I live in a very small country, a very small town. So my town has about 13,000 inhabitants, very small. So we, for a long time, we didn't have a good satellite image of the region. Very bad. It's only changed a little time. Okay, so we need the image, often usually by satellite, but not with sufficient resolution. And if we want to get our high quality satellite image, we have to pay a lot of money. Well, we can make this by manual survey. So you get a lot of people go and check the position of the trees and make the annotations, and we create a database of this. But it's very labor intensive. Thus, combining all of this, we have a very expensive method to manage the urban trees. So, our proposal is try to minimize the cost of the method using for the image drone. It's nowadays we can get drones relatively cheap, and it can produce a high quality image. And to minimize the labor intensive task, we are proposing to use machine learning, make the computer work for us. Okay, this is an overview of the methods. We pass through the image acquisition and all the processing to prepare the image to the machine learning process. We tiled the image. I will get some details of this process later. Just now is just an overview. We tiled the image we had, so the typical process for machine learning. We had our data set of images, so we pre-processed them, tiled, cropped, divided them, split our data set for training the model, validate the model, and then test the model. And we evaluate the results after that. Okay, how we did the data collection? This is the background image is OpenStreetMap, but the grid is each square is an area through a drone flight we did. We used DJI Mini 2, one of the cheapest drones, I think, in the line of DJI drones. But we had, they call the Fly More combo, which comes with 3 batteries. So each square, we planned to use all the 3 batteries with some security margin to get the drone back. We set 100 altitude with terrain correction, so the drone keep always 100 meters from the ground, and we used 75 overlap to front and to the side images. With that setup, we get after cleaning a lot of images, we get 12,767 files. Each file with 4,000 by 3,000 pixels. It's the default resolution for the DJI Mini 2. What we did in this cleaning? When we flight, it's a pre-programmed flight, so we get a lot of images in the board, in the edge of each square. And this is when the drone are not aligned to the flight, so we have to discard this image. I think about 3,000–4,000 images was discharged. I hope I get this recorded later. Well, the image was, our time frame was from April to June this year. Why this time period? It was the time period my institution, my education institution was on a strike, and I could get the drone to use when it was not used by the institution. And we used always the image was taken between 11 a.m. to 2 p.m. to minimize the shadows of although, as I said, I live in a very small town, we don't have large buildings, but to minimize the shadows and everything, we fight in this time frame. We could build an art mosaic after all this image collection. We after about 11 hours of time processing, we get an image of 119,000 by almost 115,000 pixels with a ground resolution of 3.2 centimeters per pixel. So a high quality image to be the base of our work. For curiosity, the orthomosaic we get was about 32 gigabytes when we exported as GeoTIFF. Then we tiled it with different zoom levels using GDAL. This is a comparison. This is the image we get from Bring. It's the best we have of satellite image for my city. And this is the ortho. Unfortunately, the projector are not make evident the difference. But after the conference, I can send the file, and on the computer monitor, it's more evident the difference in resolution and how we can see better the trees, the definition of trees and everything. Okay, so the process started. We had first the image we cropped when the image does not have a regular edge, and removed. You can see in the orthomosaic, we have large areas with no information, so this get out of the process. Okay. Yes. Now, after that, the algorithms we used, we cannot make them run efficiently with the image as a whole. So we have to split, slice the image. We used 412 pixels by 412 by 412 pixels using the software Sala I, slicing the hyper-inference. So the software make the slice the images for us, but it keeps the tile position, so we can build back the image after the process. So when you use this method, we can overcome problems with the memory constraints when using a machine that does not have a powerful GPU. Okay. Well, our process for training, validation, and testing. We used, we split our data set 70% for training, 20% for validation, and 10% for testing. And we randomly picked the data set to each of these chief of this separate data set. And what algorithm we use? We use a CNN, a convolutional neural network called UNet, but we use as backbones. We tested two backbones, ResNet 34 and MobileNet in the version 2. What is these backbones? We need a lot of images to get a well-trained model to segment the image and identify the trees. So these two, ResNet 34 and MobileNet V2, are pre-trained models to identify vegetation. And we use that as an encoder to the UNet CNN. And other parameters, we use binary cross entropy to the loss function, the optimized Ross Adam, and a batch size of 8 images. We run it using Python. Python has excellent libraries to work with machine learning. We use PyTorch. So the images were converted to the format used by PyTorch tensors. We use a normalization tool using the mean and the standard deviation. So all the images get similar values to not impact the model. And okay. And it has a smaller area detecting the tree. So at first sight, we see, oh, you got almost 100% accuracy. The model never get an error. It's far from the truth. What happened here? We have the accuracy. We can define it as the percentage of what we get right divided over what the total of occurrence we had. So my student used it to calculate this accuracy, all the area. So the background counted to the classification, and if you get the percentage of the background in relation to the trees, we had a background of 99.9, I don't know, percent of in relation to the trees. So we have to adjust the method to the evaluation. Okay, but we see we tested many thresholds to the model. The threshold is a percentage we inform the model to the model consider what is a tree and what is not a tree. So we inform them, look, if you get a probability of the 20%, 30%, this is the threshold. If you get 30% of this pixel is a tree, consider it a tree. So we test various thresholds and we get the values. I think, but it's omitted here, unfortunately. But if I can trust my memory, there is the threshold of 0.2, 20%, and for the MobileNet, threshold of 0.3, 30%, was the optimal thresholds to use with this particular problem. And we planning to advance this research. This is comparing the ResNet classification and identification of the trees. This is the ground truth, the marked, the image marked, manually marked to feed the model. This is the output of the ResNet. This is the output of the MobileNet. You can see it's very similar, but no, I think he used the same image. The MobileNet has sharp edges, has a smaller area of detection. And I don't know my time, and this is the work. Thank you, and I'm open for questions.